This is the third video in the Art of HF series about forecasting. In previous videos we selected our frequency and then we built an antenna to hit our distant station, which was 1,000 kilometers away. This time we want to do planning and forecasting for this link into the future. And by the future we don't just mean today, because we covered time in the frequency video, but we mean several months into the future. Because when the seasons change, the ionosphere changes. And so the ionosphere in January, in the winter, is very different to in July. So to model that, we can use the path tool again, click on our link, and have a look at optimal frequencies for different months. So here we are looking at January, so we can go ahead and open that link up in a new tab, and let's repeat that for the summer, for July. Let's go and open up that in a new tab. So here's January and there's July. Quite different. So January looks very busy. I can pick from many frequencies across the spectrum. In July, our frequency of choice, 11 megahertz, has collapsed in the middle of the day. We can't use it. We can use it in the evening, but there's a lot less choice here in July than January. So that allows us to pick the month, and we can use the path tool to find the best frequency far into the future. But what if we want to go further than a few months and look long range, look into next year? Well, you can do that using solar charts and solar predictions. And so that is the sunspot number here. So the sunspot, or R12 number, is a measure of solar activity. And there's a link here to a page. This page is from the Belgium Observatory, and it shows the 13 years of sunspot number data on a chart. So we're really looking at the red line here, which is the average, and the scale on the left here maps to the R12 number that is in CloudRF. So we're over here in 2025, and the average here is just below 150. The forecast is, going into later this year, that's going to drop. It's going to drop down towards about 125. However, you can see the deviation in the readings. It's up and it's down. If we want to be conservative, we would go with the lower one, which is going to be about 50. So with these numbers, let's go ahead and play with this link at the top of Scotland with different sunspot numbers. So as before, we've got the HF colour schema, the 2,000 kilometre radius. It's the VOACAP engine that's going to make us a heat map, and I can see with a low sunspot number, which is low solar radiation, we have an enormous skip zone here right across the UK, and thankfully there is a return signal that's hitting the top of Scotland right where we want there, so that's actually quite lucky. So what does 150 look like? Well, if we add on 100 onto the sunspot number, there's more solar activity. So this is a better scenario, and this is an easier scenario. We're covering most of the UK with a better signal there. That's an S3 signal according to the colour key. So to be conservative, we could keep that sunspot number low. Now the sunspot number follows a 10-year cycle. You can see from 2014 to 2024. So we could actually predict off the chart here and say, well, I reckon in 6 years' time, 2030 or 2031, this number will have collapsed again, and it will be down low. It will be down towards 20, for example. So you can predict several years ahead. Now what does that mean in terms of actual signal strength? Well, it's about 3 decibels for 100 in the sunspot schema. So you could simulate that using the sunspot number, or you could mess around with the reliability here and apply the decibel loss here. So for example, if I was to put this sunspot number at a fairly middle of the road 100, which is what it defaults to, we can see what we might get in July. If I want to simulate a change in that, I could adjust the sunspot number if I've got a chart, or I could go ahead and apply some loss here in the reliability. So if I bump up the reliability, I wouldn't recommend going higher than 90% because that's taking 8 decibels off it. But if we went up to 80% reliability here, which is going to put on a 6 decibel margin, that's where we would get with higher confidence. So we lost some of the other areas, but we're highly confident we can get up to the Shetland Islands up there. Now this solar cycle is a 10-year cycle, and we've actually got historic data going all the way back to the 1700s there. So if you've got a friend down the pub who gets excited at the mention of ice ages, by all means show them this excellent data from the Australian Space Weather Forecasting Centre, and have some fun with that, because you can see that there's been a mini ice age here back in the 1700s when people were ice skating on the Thames, and there's a 10-year cycle which is evident here as we hit several minimum records and then several maximum records, and then lo and behold we're going to hit several minimum records soon. So solar activity is constantly changing, and you can plan for it using tools like this that will let you predict what solar activity will be like on a given month or a given year. But there's still about a 5 decibel range in these readings. So you could find that if you put on about 5 decibels of loss, you can plan for a worst case scenario.